Okay, enough with the homecoming chatter of how your hair is going to look and all this. That's still 2 weeks away. You have plenty of time to figure that out. So I think it'll be all right. Dresses are bought, clothes or tuxes are rented. Corsages have been ordered. So let's just wait for the 2 weeks and let's get started. So graphing and solving systems of linear equalities. So these are very similar to... Do what? Oh, that's why I asked if you had questions, and then you just continued with the homecoming chatter, so I just moved on. So, sorry. Okay, good with that. That's why I ask questions, so then people can say, hey, I have a question. Because if not, I just move on. So, on Monday... You guys got your vest color picked out? You good? Yeah. Okay. Can I go then? Yeah. Perfect. So, graphing and solving system of linear inequalities. This really isn't a whole lot different than solving a system of linear equalities. The biggest thing is here there is going to be shading, and then there are going to be either a solid or a dashed line. So, realistically, a system of inequalities consists of two variables and two inequalities. It's the same kind of thing as far as a system of linear equality. Okay? Again, like I said, there's just going to be shading, dashed line, solid line, things like that, depending on the type of system you have. So a solution then, instead of a solution like before, it was just being a single point, with a system of linear inequalities, a solution to a system of linear inequalities is where the where the shading overlaps. Okay? So whenever we have a system of linear inequalities, there's going to be some overlap because there's shading either above or below that line, like whenever we graph linear inequalities. Okay? You do everything the same way that we did with a linear inequality, so you still put it in slope-intercept form. You still find the y-intercept. You still use the slope. You're still going to use a dashed line if it's less than or greater than. It's still going to be a solid line if it's less than or equal to or greater than or equal to. But you're still going to lightly shade half of the plane. So basically, wherever, if it's above or below that line, you're still going to lightly shade it. Again, I use the word lightly because you want to be able to see if there's any distinct area. Okay, and then repeat steps 1 and 2 basically for the second inequality. Wherever the two sets of shading overlap one another, that's the solution. That's anything inside that shaded area. Okay, so anything inside that shaded area, it's not just a single point like it was before. Okay? Before, it's that single intersection point that they have, whereas here, there's a lot more values that can be a solution. In some cases, depending on what types of lines you have, if you have solid or dashed, if you have a solid line, it can still fall on that line if it's shaded. Okay? If that's where their overlap lies. If it's a dashed line, then no, not in some cases that it will actually work in terms of our solution. So if we're going to graph these, so if I have the first one, and if we zoom in to make this a little bit easier, okay, so it says solve the system graphically. So first thing we want to do is we want to put this in slope-intercept form. So in doing that, I'm just going to move the x over to the other side. Whenever I do, I'm going to have y less than or equal to negative x plus 4. So I'm going to go ahead and graph that. I'm going to do one thing at a time and then kind of figure out where I'm at, okay, as far as my solution is concerned. So I'm going to start at 4. I'm going to have my point here at 4. And then I'm going to have a slope of negative 1. And I'm just going to kind of go from there. Is it a solid or a dashed line? Solid line. So then I'm just going to run a black line through those two, or through those points. There. Now, again, it is, you want to run the whole thing across my graph. Okay, across the whole thing. Not just a small little section, but I want to run it from one end of the graph and maybe even off of it to the other. Now, if I'm going to shade and it's less than or equal to, is it going to be above my y-intercept or is it going to be below my y-intercept? If it's less than, below. So then I'm going to have, now here's how I do it, okay, and I'm not telling you have to do it this way, but students usually have a hard time shading lightly. So usually I just kind of take my lines and kind of tell and have maybe arrows going that way, like little bitty arrows. I might even do something like this to where I know, okay, I need to go this way, so that way I know which way I need to shade. Okay, I may just run little arrows kind of off to the bottom side because it's below. Okay, I may draw those like little lines so then I have an idea of where there's going to be an intersection of my shaded area. It's really up to you as far as what you want to do. So then for the second one, I'm going to move x over to the other side. So I have negative y greater than negative x plus 2. Now, am I done there? No, what do I need to do? I need to flip that sign. I basically need to divide everything by negative 1. So my equation to my line is going to be y less than x minus 2. Now, why did I have to change it from greater than to less than, Mac? Because I divided by a negative, right? Or multiplied by a negative, however you want to look at it. Okay? So don't forget that if you have to multiply or divide by a negative, make sure you flip that. You don't just change all the signs, you've got to flip the symbol too. So then if I'm at negative 2, I'm going to put my point here at negative 2, and my slope is 1 over 1. Bless you. I'm going to have a dashed line. Okay. Or I can do it the easy way and cheat. Now, am I going to shade above or below that line? Below. So if I shade below, that means it's down here. So where my overlap is going to be all of this area. Okay, if I just run it in red, is where everything, okay, kind of fits in here. It's below the red line, it's below the black line, so where that overlap is that very bottom section. Okay? making sure that you change the sign. Okay, flip the symbol, things like that. Okay. On 2, we have 3 systems, or 3 equations. That's okay. We can have 5 if we need to, and we'll kind of go from there. So we want to solve the system graphically. So in doing that, let's just fix the first one to where it's in slope-intercept more. So I need to move the x over, so I have negative y less than or equal to negative x plus 2. Now I'm not finished because I have the negative, so I'm going to change all the signs and I'm going to flip the symbol to a greater than or equal to, make it x and then minus 2. So we're going to graph this one. This one's going to be hopefully the toughest one to graph. So x is greater than or equal to x minus 2. So I'm going to go down to negative 2. I'm going to go up 1 over 1. Now, is it a solid or a dashed line? Solid line. So, run everything through here. Now, this is why I kind of draw those little arrows instead of shade, because I'm a little bit OCD when it comes to, I'd rather just have like the one spot where everything hits and kind of where everything's pointing, because if you get into shading like 3 lines, to be perfectly honest with you, you're going to stare down at it, okay, because you have a hard time. You haven't taken an art class yet, maybe, to learn about shading. All right? And so you just start scribbling like my 3-year-old and just coloring and hoping you stay between the lines. Okay? So if it's greater, that's why I just kind of like these little arrows of, okay, this is the direction I need to go with my shading. Now, again, you don't have to do it that way. If you think you can shade and you're good to go, that's fine. Okay? But usually whenever we get more than just the 2, it gets really dark in some places because the shading got so, and it's like, I don't know what part is right and which one is wrong. So then the second one, so just know that that is another option. So if we go with x greater than negative 2, so what kind of line is this? Vertical through negative 2. It's going to look something like that, except for what needs to change. Dashed line. I can kind of cheat the system here. So I have my dashed line here. Which way am I going to go, left or right? Which way is it pointing? Right. So again, I'm going to go this direction. Again, if you want to shade, that's fine. I have no issue in that. Just make sure you do it very lightly. Now, common sense should tell us, where are we actually looking to shade? Are we going to shade below that red line? Are we going to shade in this area down here? Why not? So I'm really looking at, I've just basically taken 1/4 of my graph away, right? Before I've even done anything, because I'm only going to stick to this area up here. Okay, because it's a solution, it has to fit every single case. So the only case that it's going to fit is kind of up in that top right corner, or this area here. Now the last thing I need to do is I need to go with my 3rd line. So in doing that, if it's y is less than or equal to 3, what kind of line is it? Horizontal, right? Is it solid or dashed? Solid. And then solid at 3. Where am I going to shade here? Above it? Is it going to be in that little triangle, or is it going to be everything above it? It's going to be in that little triangle, right? Okay, it's down here. So it's basically where all those three arrows meet is my area of my solution here. I like just doing the one just because it looks better, but that's just me. Actually, if you have to actually graph or write a system of inequalities, okay, I need to look at everything that I have involved, because they're not going to have random shading and then a darker area of shading. They're just going to give you where the solution lies. Okay? So if they're going to give you where the solution lies, it doesn't matter to me which one you pick, but you're still just going to write the equation of a line. So like if I just look at the dashed line, first off, if it's a dashed line, are we above the dashed line or are we below the dashed line? Where's it at? Isn't it above? It's above here. Okay? It's above the dashed line. So if I'm going to write the equation of, or the inequality of the dashed line, it's just going to be y greater than. Is it going to be greater than or equal to? Greater than. Why is it not equal to? Because it's a dashed line. Okay? What's the slope of my line? What is it? So it crosses here and then there. So 2/3. 2/3 x. Does it have a y-intercept? No, it's just 0. You can put 0. That's up to you. Then, now I need to look at my solid line. Is it above? And this is where students get a little tricked up because it's a pretty steep line. Is it above or below? It's below. Okay, or again, find your y-intercept and go from there. So it's y, is it less than or equal to? Less than or equal to. What's the slope of my line? Negative 4, down 4 over 1. 4x, and then slope intercept plus 2. Biggest thing here is knowing, is it going to shade above or below my line and going from there. Assignments on Canvas.